Let's answer these questions instead. Now, let's say this function represents the velocity. So what you're looking now is not at a position graph or a displacement graph, it's the velocity graph, okay? So I want you to answer this question. When is the particle moving left and right? When is it stopped? When is it going the fastest? In what direction? And when is the acceleration 0? When is it positive and when is it negative? So again, I would like you guys to take a couple minutes and work with the partner and people at your table. And I will come back and check your work. Okay, so let's discuss the answer to this. When is the particle moving left? Well, the particle is going to be moving left whenever the rate of change is negative. Okay, so if this is the displacement function, when it's moving left is when the velocity would be negative. Velocity is rate of change of your position or of your displacement. So places where we would be moving left are right here, in this particular section. So that's between 1.5 and 3. In this particular section, between 4 and 5, we have a negative slope. And that's it. So those are the places where the particle would be moving left. Where is it moving right? Well, it's going to be moving right whenever the displacement has a rate of change that's positive, okay, or the slope is positive. So between 0 and 1, it's going to be moving to the right, which is kind of obvious. You start at 0 and you end up at 1. And then you're also going to be moving to the right between 3 and 4 seconds, and between 5 and 9 seconds in this whole area right here, because the slope is positive. Okay? So you got to think about looking at slopes when you're thinking about velocity. And the thing we got to get tied up with is that you see down here the graph is negative, so you think negative values, but the displacement is what's negative. We're answering questions about velocity. We have to think about the slope of the displacement graph. When's the particle stopped? The particle will be stopped when the velocity is 0, or the rate of change is 0. So that's going to be on these sections where the graph goes flat. So right here, and on this interval right here. And that kind of makes sense because in this whole time interval, in this half a second time interval, you can see that the displacement doesn't change. If the displacement doesn't change, that means the particle's not moving. Okay, so when is it going the fastest? Well, that's when we will have the highest velocity, and so that's going to be when the graph is the steepest. And so if you kind of analyze the slopes, I think we're probably tied, unless you actually calculate it here. Here we've got a slope, and this slope, they're pretty close. This slope is 1, and let's see here. We go up 2, over 2, this slope is also 1. So that would be when it's moving the fastest. Now we also want to consider negative. That's when it'll be moving fastest to the right. We also have to consider negative slopes. Like in this particular section here, it's a run of 1 and a rise of 1, 2, 3. So in this particular section right here, the speed is actually 3. Okay, the velocity is negative 3 because that's the slope right here. So this, I guess, would be the answer for when it's going to the fastest. So whenever the graph is the steepest, whether it's up or down, increasing or decreasing. Okay, and then as it says, in what direction is that? Well, that's to the left, since the velocity is negative. Okay, last question. When is the particle farthest away from the origin? Well, it's going to be farthest away from the origin when it has its maximum displacement. Okay, so notice that on the maximum displacement on the left is 2 units, because we're negative 2. So we're actually looking at function values here, not slopes. And then on the other side, like between 9 and 10 seconds, we're out, looks like about 2 units away. So 2 units is the furthest we get from the origin. Okay? All right, so now I'm going to consider this graph again. But now let's assume that this graph doesn't represent position anymore. Okay? Let's say that it represents velocity. Let's see if I can get this to work. Seemed easier than it is. All right. Same graph. Let's answer these questions instead. Now, let's say this function represents the velocity. So what you're looking now is not at a position graph or a displacement graph, it's the velocity graph, okay? So I want you to answer this question. When is the particle moving left and right? When is it stopped? When is it going the fastest? In what direction? And when is the acceleration 0? When is it positive and when is it negative? So again, I would like you guys to take a couple minutes and work with the partner and people at your table. And I will come back and check your work momentarily. So if I can get the teacher to push pause for a second, work on this problem for a few minutes, and I'll come back with the answers. Okay, so now if this is velocity, now the way I'm looking at the graph is this is positive velocity up here, this section. So that means the particle is moving to the right. Now this is negative velocity down here. This means the particle is moving left. And here the particle is moving right again. So when I answer these questions, when's it moving left? Down here between 2 and 7 seconds. When's it moving to the right? Between 1 and 2 seconds, and between 7 and 10 seconds. Okay? Remember this graph we're looking at now is velocity. When is it stopped? Well, it's going to stop when the velocity is 0. And if this graph depicts velocity, the place where it's 0 is at 0, 2 seconds, and 7 seconds. At those places where the actual graph goes across the x-axis. Okay? Question 2, when is it going the fastest? Well, if this is a velocity graph, it's going to be going the fastest when it has the maximum value. So it looks like, in this particular case, it's about 2. Down here it's at negative 2. Okay, so if we're just talking about speed, then our answer would be the maximum speed is 2. And it happens in 1, 2, 3 different places. If we are considering the sign as well, the maximum velocity would be positive 2, which is up in that interval up there. Okay. So both of those, in which direction? This one would be to the right, it's positive velocity. This one, these 2 points would be the left, since it's negative velocity. And when is the acceleration 0? Well, acceleration is the rate of change of velocity. And if this is velocity, where is the slope of this 0? It's right here, this time frame, between 1 and 1.5 seconds, and between 9 and 10 seconds. That's where the graph goes flat. When is the acceleration positive? Well, that's whenever we have a positive slope. So in here, and right there. And when is the acceleration negative? This area, that's it. Okay. So there's a lot of questions like this on the AP exam where you don't know what the function is and they just give you a graph and you need to consider what does the graph represent? Is it displacement? Is it velocity? Could even be in the graph of acceleration. And you'd be answering some pretty simple questions, but unless you really understand what you're looking at and can understand whether you're looking at looking for the values or you're looking for the slope or what, they'll be harder questions. Okay? So always try to determine what it is you're looking at. Okay, so let's look at some more examples of velocity. Let's say instead of a graph, we're actually given a function. Let's say we're given this function, 160t minus 16t squared. And let's say this function represents the height of a model rocket. So we shoot a model rocket in the air, and this function represents how high it is as a function of time. And let's say that the height is in feet, and t is in seconds. So, first question you might be asked is to find the velocity of the rocket at a particular time. So let's say we're asked to find the velocity at t equals 7 seconds. Okay? Well, since we know a function and we know that the velocity is going to be the rate of change of the position, which in this case the position is height, to find a formula for the velocity, all we need to do is find the derivative. And luckily this is an easy enough function and we can just use the power rule for it.